Absolute value equations and inequalities is going to be something probably like you have never seen before. Keep in mind what you know about absolute value. You know that it's the distance between a number and 0 on the number line. So like the absolute value of 4 would be 4, or the absolute value of -4 would also be 4. Absolute value is always positive. So we're going to see how this fits into equations and into inequalities. So our target is that I can solve equations and inequalities involving absolute value. Just like before, the ultimate goal of any equation or inequality, so equation, that's what we did in Chapter 2, inequality, that's what we solved in Chapter 3, is to isolate the variable, meaning get it on one side of the inequality symbol by itself. And here is summed up into 3 steps how you go about doing that. First, clean up the equation. That was where we might have had to apply the distributive property or combine like terms. Second is reuniting the variables. If you have the variable on both sides of the equal sign, then you're going to have to move it from one side to the other so that you can keep that variable on one side by itself. And then lastly, undo what's happening to the variable. You do that using inverse operations. Here's where it's a little new. Once the variable is isolated, and when we're talking, this is what we're talking about with absolute value. Split it into 2 equations or inequalities. So when you have an absolute value, here's what you'll need to do. Once it's isolated, then you're going to split it into 2 equations or inequalities. Here's what I mean by this. So let's take this equation. The absolute value of n minus 5 equals -2. So we're going to undo what's happening to the variable. We're going to undo subtracting 5 by adding 5. So it cancels here on the left side. What you're left with is the absolute value of n is equal to 3. You're going to split this into 2 separate things. So the absolute value of n, that could be said that n is -3 or n is 3. Here's why this works. If you put -3 back into that, the absolute value of -3, that could equal 3. And likewise, if I put +3 into that, the absolute value of +3 is also 3. And you can put both of those into this original equation because either way, the absolute value, positive or negative, is going to be +3, minus 5 is going to be -2. So here's one that's a little bit more complicated. So we're going to start by adding 5 to both sides, cancels on the left. So what you're left with is the absolute value of 3x minus 6 is equal to -2. Now I want you to think about this. I have an absolute value, whatever this isn't being, that what this is saying is that the absolute value is going to be equal to -2. Well, here's the deal. That is no solution because an absolute value cannot be negative. So if you see this, that you have anything inside the absolute value lines, inside those boxes, if anything is equal to a negative, then it is no solution. So it doesn't matter what is in that inequality box. If it is isolated and it's set equal to a negative, then it is no solution because that can never happen. An absolute value is only positive. When you have an inequality, you're going to solve it in a very similar way. So you can write absolute value inequalities as a compound inequality, meaning that you have 2 things that variable is being compared to. The graphs below show 2 absolute value inequalities. So let's look at this one here on the left. The absolute value of n minus 1 is less than 2. Here's what this means. It represents all the numbers with a distance from 1 that is less than 2 units. So some possible solutions, you can see this graph. If I put 0 into that inequality, 0 minus 1 is -1. The absolute value of -1 is 1, and that is less than 2. Let's put the +2 in there. If I put 2 in there, the absolute value of 2 minus 1, that would be 1, and 1 is less than 2, so that checks out as well. That's what's being meant right there. Now on the other side, notice it's the same on the left side of the inequality, but the right side is different. This time it's greater than 2. What that means is that it represents all the numbers with a distance from 1 that is greater than 2 units. So what's graphed are possible solutions. So let's put -4 into that. The absolute value of -4 minus 1 is greater than 2. Okay, so -4 minus 1 is -5. The absolute value of negative 5 is 5. 5 is greater than 2, so that makes sense. Likewise, I could put positive 6 in there. 6 minus 1 is 5. The absolute value of 5 is 5. Both of those would work, so anything that's graphed in there would work. Now here it kind of sums it up for you. If you have that absolute value is less than a number, it's going to look like one of these kind of inequalities, meaning that it's falling between those. It's like you have bumpers, and it can come to here but not quite to there. And this would also apply if it were greater than or equal to. The difference is those circles would be dark. They would be colored in. To solve an inequality in this form where it is greater than, what that's telling you is it's the split. It's like the waters have been parted. So if it's less than, then it's going to be filled in the middle. If it's greater than, it's going to be filled in on the outside of those barriers. All that is pretty overwhelming, I know. And solving absolute value inequalities is not one of those things that I think is essential for you being successful in Algebra 1. You will see that again in Algebra 2. An absolute value equation, I do want you to be able to do that. This inequality business is just extra. That will be considered like the bonus on a quiz or on a test, but I wanted to go ahead and expose you to this. So here you see that the absolute value side is isolated. It's greater than 5. Now think back over here. Since it is greater than, the graph would look like this. It's going to be split in the middle. So now that I have the absolute value isolated, I'm going to separate it into two possible inequalities. I have this where it's greater than a positive 5 and that this could be a negative 5. So let's go about solving it now. Just like we did earlier in the chapter, we're going to subtract 4 on both sides. I'm left with 2x, 4 minus 4 cancels, is greater than 5 minus 4 is 1. So then undo multiplying by 2 by dividing by 2. And that cancels. So x is greater than or equal to 1/2. Okay? And then the other side. Let's do this one. I'll do it in red so it doesn't mush together as well. Well, let's do blue. Okay, so we're going to subtract 4. Well, that looks more like purple than blue, doesn't it? Oh well. So we're subtracting 4 because we're undoing adding. So 2x comes down, is greater than or equal to negative 5 minus 4 is negative 9. Then I will undo multiplying by 2 by dividing both sides by 2. X is greater than or equal to negative 9 over 2, which you could turn that into the mixed number of negative 4 and 1/2. There you go.